All right, wait another couple of minutes here. All right. So I'm messaging some people here privately. Make sure you follow those directions that I'm typing in for you, okay? Do try your hardest to print out your exam. It's okay if your exam is another room, you got to walk over it. So I want to see the whole desk area and your hands on the desk. I don't care if your face gets cropped out. I'll know who you are at the beginning, and then okay. Anyway, so let's go ahead and go over the review sheet. So I posted the review sheet a couple days ago. Last night after midnight, I actually posted the answer key. So if you want to just watch me do it, that's fine. It's already written out for you on and posted on Canvas for you. So are you all ready? Where's the rest of you? There's only 19 people here, and 2 of it is me and my accounts of 17. I'm hurt here. This is a lot like, well, actually, no, we have, I keep forgetting. See, like Cal State Fullerton, next week is final exam week. So we only meet one time next week at Cal State Fullerton for them to get the final. So some classes are Tuesdays, some classes will be Thursdays for a Tuesday-Thursday class. But for us, we meet both days next week. So I don't even know what I'm going to do Tuesday next week. Madison, do you have any suggestions?
We could definitely have the potluck we discussed last time, play random math games.
Oh, potluck. More review? I don't know what else. If you have questions, you can ask me. I don't really have another review sheet to give you, but you can study over the weekend, and then you run into questions, ask me on a Tuesday. Damaris, how are we doing? Damaris, how many? Are you a biology major, you said, or computer science? Oh, computer science, huh?
Yeah, computer science.
Oh. You want to work for IT? I'm just joking.
Probably not specifically that field, but roughly.
Every time I get a call from the IRS, it's a guy with an Indian accent. They want my social security number. I don't know why I thought of that. Oh, because the scam phone numbers, there's a problem with your account. I like the King of Nigeria emails better. When the King of Nigeria used to email me one time back in the day, he said, I've been looking at how you're good with money and you manage it well and you're a trustworthy person. So I have $20 million that I need to deposit into your account. No, I had the king, okay? You may have had the prince of Nigeria, but I had the king of Nigeria, okay? The top person. And The story goes, he'll deposit $20 million into my account, and then he'll remove it a couple months later, and as a gift to me for my service of letting him hide his money in my bank account for a couple months, he'll leave $1 million in there for me. All I have to do is give all my information and a couple $100 for some transaction fee that he cannot use his own funds because of excuse XYZ. And that's it. But I didn't go through with it, and now the King of Nigeria does not talk to me anymore. All right. Find the function. So one of the things you want to do when you're studying exams, but make sure you study and do the problems first exam and second exam, which is a while. Put them on a blank paper to try to work them out. Don't just keep reading them. You guys class really doing well. Just make sure you keep up the good work. So here we're going to use the product rule because it's a product. So it's this guy times this guy. Your dog something to first times the derivative of the second. So what's the derivative of the second? It's something to the third power. So 3 times that something. The second power times the derivative of the inside, which is 5, plus the second times the derivative of the first, which is 12x cubed. This is first times the second plus the second times the first. So, as far as simplifying, all you guys know is that 3 times 3 is 9 times 45x to the fourth times 5x plus 4 squared plus 12x cubed times 5x plus 4 cubed. And you can stop right here. Are we good there? I know the back I like this to factor it further and go further, but you can stop here on this test. And by the way, this is all on campus for you, okay? I posted it already. And number 2,
For in the first part of it, we get the 45 because it's 3 times 3 times 5, right?
Yes.
Okay.
Y is the natural log of x minus 5. So, what was I going to say? Well, this is the line where you got to take the derivative and you plug in the x value, x equals 5, right? At x equals 5. So the derivative. So how do you take the derivative of natural log? Well, you're taking the natural log goes on the bottom, its derivative goes up top. And you plug in 5. That's 2 over 10 minus 5, which is 5. So 2 over 5, that's the slope. And that's all I wanted. Now, remember on the first exam, I asked you to find the slope, find the equation of the tangent line, find the normal. The equation, well, you go further. Here, I asked the equation says natural log. When you plug in 5, you're going to get a messy number. Number 3, find the derivative of f of x equals 7x over 4x minus 3. So this is a quotient, therefore we're going to use the quotient rule. Bottom times the derivative of the top, which is 7, minus the top times the derivative of the bottom, which is 4, all over the bottom squared. So remember, on the quotient rule, you leave the denominator alone, but multiply at the top as much as you can. 28x minus 21 minus 28x, or simplify as much as you can. So the 28x's cancel out, so negative 21 over 4x minus 3 squared. Oh, my physics major is not here. Desiree. No, this physics major. And James, the one with the library of books behind them. Any questions? Any comments? All right. Let's go to number 4. Find the absolute maximum of the function f of x equals x squared minus 10x plus 8 on the closed interval negative 2 to 6. So remember, if you have a closed interval, and sorry, I was reading the chat here. If you have a closed interval and it's a continuous function, you're guaranteed a max and a min. So what you're going to do is you find the critical values. So take the derivative, set it equal to 0, and then let's see here. Your critical numbers are x equals 5. So you list them along with the endpoints. Remember, the endpoints automatically make the list. Now, you're going to plug every single one of these in. The highest one is your max, the lowest one is your min. Now, where do I plug them in? The original, the derivative, or the second derivative? Type in the chat what you think is the correct procedure. Original f or f prime? Yes, original is correct. OG works as well. So f of negative 2 is negative 2 squared minus 10 times negative 2 plus 8. So that is 4 plus 20 plus 8, which is 4 plus 20 is 24 plus 8 is 32. F of 5 is 5 squared minus 10 times 5 plus 8. That's 25 minus 50 is negative 17 plus 8. Sorry, 25 minus 50 is negative 25 plus 8 is negative 17. When you do the calculation faster than you can talk, it's actually sometimes a problem. Negative 17. F of 6 squared minus 10 times 6 plus 8. So 36 minus 60 is negative 24 plus 8 is negative 16. All right, so out of all these, the highest value is 32. Right here. So you would say the absolute max, f of negative 2 equals 32. The absolute min is the minimum value you see, which is this guy right here, right? Negative 17. So say where it's located at 2, f of 5 equals negative 17. So this is the final answer right here. Any questions? Cole, how are we doing over there? Number 5. Find dy over dx by implicit differentiation. So for finding dy over dx by implicit differentiation, you're taking the derivative of both sides with respect to x. So The derivative of x with respect to x will be 1, but the derivative of y with respect to x will be dy over dx. So this is 3x squared plus. Now, on this guy, it's going to use the product rule. First times the derivative of the second. Derivative of y squared is 2y times dy over dx. A second times the derivative of the first, which is 5. Equals, what's the derivative of 18y? Well, it's 18 times the derivative of y, which is dy over dx. So let me clean this up a little bit. 3x squared plus 10xy. You see how I changed the 5x and the 2y being multiplied to 10xy? It's a good habit to do that. Don't keep writing 5x times 2y times dy over dx. I mean, it's not wrong, but it doesn't make you look good. For a mathematician reading your work, you're saying, this guy keeps writing 5x times 2y. Why doesn't he change it to 10xy? We wonder these things. We judge you. Right, Madison?
Unfortunately, yes, that has become apparent.
Unfortunately, yes. Yes to what? To that we judge you? Yes. Now, minus 10xy times dy over dx. So I'm getting the dy over dx to one side because I'm trying to solve for dy over dx. There we go. What's next? Factor out the dy over dx, right? And then you divide by what's inside the bracket. Any questions so far? So number 6, f of x equals x squared minus 3x. Again, for those of you who came in late a little bit, this is all already posted on Canvas for you. That's probably the reason some people are ditching today, huh? It's because of my fault. Oh. It's either that or Thirsty Thursday. Oh, no problem, Damaris. The derivative is limit as h goes to 0 of f of x plus h minus f of x all over h. So that's the limit definition of the derivative. Make sure you put that in your cheat sheet. So we already increased it that you can have 2 cheat sheets, right? You know what somebody said in my earlier class? They said, oh, you said I can take all the 3 of my old cheat sheets and staple them together. Can I just do that? So now we're increased it to 3. See what happens? You give someone an inch, they want a mile. I'm like, I said 2. So I have to redo all 3 of these to 2? That's a lot of work. See what happens? I go, well, we've had a couple sections that we did since the last test anyway. You got to include those in it anyway. He goes, oh, yeah, that's right. I'll just redo it. I'm like, oh, why do we even have to talk about this? F of x plus h is x plus h squared minus 3 times x plus h. So you plug it all in, so the derivative is equal to limit as h goes to 0 of f of x plus h, which is already done, minus f of x, that's the question, all over h. Now, if you remember, if you were to plug in 0 for h, you're going to get 0 over 0. So you got to do some algebra, simplify it. So for those of you who haven't done this, which is probably all except for like 3 of you, go ahead and work on it. Except for 3 of you. Don't worry, I know 3 of you did it already. We all know who those 3 people are. Oh, no, actually, this is a good class. I'm sorry, probably like 7 of you. My morning class, I would say like 2. You know what somebody complained to me about in my college algebra class? They said that I am a harsh grader, and just because their work is incorrect, but they have the correct answer, they should still get points. Like they don't like it that I take points off. I'm like, yeah, you can't just have everything wrong and boom, the right answer appears out of nowhere. No apologizing. Sorry, I did something inappropriate here. They want points too.
I think if it was the other way around, I'd be mad. Like if I did everything right and that like the last step I messed up, then like I would like be really mad if I got like a bunch of points marked off. But if you do everything wrong, but you get the right answer, that looks like suspicious. So
no, it doesn't look suspicious. It damn is suspicious. And it's not just one question, it's like every other question. I can see one question, okay, you got lucky or whatever. Oh, do you have instructors that like you do everything right, but you messed some little thing up, and instead of going -1 or 2, they go like -5? Oh, wow.
I took when I took trig, we were told to write the answer in a certain form. I got the right answer, but I put the decimal form as opposed to it in fractions. And I got the entire question marked wrong, even though I did all the math right. And that was mildly frustrating. I mean, I did okay on the exam. It's just like I lost a lot of points because of that, which was kind of irritating.
Oh, was that at the, like, let's say like you took the, like, let's say the answer was 1/√3, but you just put a decimal approximation?
Yeah.
Ooh, was that tricky at Fullerton College?
Yeah.
Yeah, that's rough. Was it a Scantronic? No, it was online, right?
Yeah, it was online.
Okay. But was it like a computer grading it, or was it a human being, or like a professor grading it by hand?
It was a professor grading it. I took college algebra with a computer grading it, and that was its own set of like irritating problems. But yeah, it was a actual professor grading it.
I mean, like, I sometimes make a mistake grading it, and the students sometimes say, hey, you know, are you sure you meant to take 5 points off here? Because I just did this right. The only mistake I made. And I look at it and I go, yeah, sorry. I was probably a little tired, and I didn't realize it. You do deserve another point. But then once I look at it, I say, no, I graded it correctly. You don't deserve any more points. Then they start arguing with me. I go, like, you do realize I'm like one of the more generous instructors here, right? Like you have another professor look at it, they probably even give you less points, but that's when it gets annoying, when they argue. The worst is like end of the semester. This is a hint. This is like a message for you guys. Is like end of the semester, grades are turned in. I'm already on like Christmas break, or in this case would be summer break, and they keep emailing me, oh, is there any extra credit I could do? I go, no, we're in like Memorial Day weekend. The semester is over. The office is closed. We're done. Sorry, you got the grade that you got. And the person, like, this is like in the classroom, they didn't care for 15 weeks. You can tell. They're in the classroom. They're sitting there. They're talking to their buddy. This is like Math 40. They're just half-assing it the whole semester. Now they're pretending like their life is over because they didn't pass math. I'm like, hello, you're not the first person who didn't pass the math class. You know, life is not over. Anyway, sorry, I'm venting a little bit. You guys are my therapy for the afternoons. X plus h whole quantity squared is x squared plus 2xh plus h squared. So you x plus h times x plus h multiplies out to that. Distribute the minus 3 is minus 3x minus 3h. Distribute the minus sign, minus x squared plus 3x all over h. Let's see here, simplify. The x squared and the minus 3x cancels out. The negative 3x and the plus 3x cancels out. So you get limit as h goes to 0 of 2xh plus h squared minus 3h all over h. Factor out the h. H's cancel out. Now let's take the limit as h goes, limit as h goes to 0. I was trying to flick this hair off. I don't know how the hair, little pieces of hair gets on my eye. Oh, it's from my wrist. That's why. Well, I don't have any hair up here. 2x plus 0 minus 3. I plugged in 0 for h, so 2x minus 3. So make sure that when you do this, you got to show the work properly. So it's important to write the f of prime of x equals limit as h goes to 0. You got to have the limit as h goes to 0 of the difference quotient. Then once you take the limit, then you drop it, you plug in 0. All right, Madison, don't worry, I'm not going to say anything. I just was curious. All right, then let's move along to number 7. The integral of 5 cosine x plus e to the 2x. So because there's a plus sign here, you could just treat each problem separately. So the antiderivative of cosine is sine. So this would be 5 sine of x. The antiderivative of e to the 2x is itself. Divide by 2. And then plus c. So when it's e to the sum number times x, that's the basic type. It's just the say itself, divide by 2. Now, if it was like e to the x squared, then they get tougher. But if it's e to the some number times x, you just divide by that number, and that's it. All right, moving on to number 8. So this one, again, you want to rewrite. Now, the second one, I'm not going to rewrite 2 over x as 2x to the minus 1. Here's why. Because if I add 1 to this, it's going to be x to the 0, divide by 0. That makes no sense. So what you realize that this is going to be the special case that it's 2 times 1 over x, and when you take the antiderivative, it's going to be a natural log. So add 1 to the x1, negative 4. Divide by negative 4, so 8 over negative 4 is negative 2. Plus 2 times the natural log of x plus c. Any questions? All right.
So, Professor,
Now,
you're just finding the antiderivatives of each separate thing, and
yeah, when it's an addition or subtraction, yes, you just take the antiderivative of each one individually. On a plus sign or a minus sign, you can just separate them as 2 separate questions.
oh, okay.
Yeah, but like the next question, like question number 9, that's like section 5.5, the use substitution.
Right.
So in this case, you can't, when it's a product or a quotient, you just can't treat them separately. And also, no, I'm not going to tell you when you use U substitution, because someone in my other class would say, can you tell us what U equals? I go, no, that's part of the challenge. So like the book did, I go, that's like the first couple of questions, but generally speaking, that's just to, because you're introducing the section for you. But generally speaking, not only, we never tell you what U is. In fact, when you take Math 152, you'll have a bunch of different techniques to learn. And then the challenge will be is, well, what technique do I use for this problem? Right now, you haven't learned many techniques for antiderivatives. So there are only a couple options. You know, either simplify, do some algebra, or use substitution. So I'm thinking, okay, here's the thing, what I do. How do I determine what to let U be? Well, you take derivative in your head. You see how this is x to the 4th, yet but that's x to the 3rd. I would say, well, I want to let U be the higher power because I run this in my head, and I'm writing it out to explain to you what I'm thinking in my head. Like in my head, I'm thinking, okay, if U equals x to the 4th, then the derivative of it would be 4x to the 3rd, which is pretty darn close to what I have there. So that makes sense. Du equals 4x cubed dx. Do I have 4x cubed dx sitting outside? Close. It's just off by a constant. That's why I don't let U equal. So someone might say, why didn't you let U equal 20x cubed? Well, what am I going to do with the e to the x to the 4th? Because du is going to be 60x squared, and then I don't know what to do there. So see the orange highlighted area? It's 20x cubed dx. I don't have 20x cubed dx, but notice if I multiply both sides by 5, I can multiply or divide by both sides by a constant. So then I get 5 du equals 20x cubed dx. So now I know what 20x cubed dx is equal to. So I can rewrite this in terms of u's. E to the u, and then the 20x cubed dx is 5 du. You factor out the 5. What is the antiderivative of e to the u? It's e to the u plus c. And what is u? It's x to the 4th. So 5e to the x to the 4th plus c. And that's our final answer. Now, this was on a test. I want to see all the work exactly written out like this, okay? So it's an online test. I want to see what u equals to. I want to see the u substitution, and then I want to see the final answer written out. Now, you can always go to scratch paper and say, you know what? A few weeks ago, if you gave me 5e to the x to the fourth and I asked you to take the derivative of this, you would say, all right, the derivative of e to the x to the fourth is itself times the derivative of the x1. What's the derivative of x to the fourth? 4x cubed. Times the 5 that's already there, so 20x cubed. There you go. You see how quick that was, taking the derivative, and you thought you were doing a lot of work? Well, that was easy. That was the good old days, but now you got to go backwards, and look at that. All right, how are we doing? Good? Ready to move on to number 10. Okay. Integral of x times 3x squared plus 8 to the fourth power dx. So again, you see how it's not a bunch of terms individually. Now you're saying, can you multiply out 3x squared plus 8? Yes, but that's not the way I intended for you to do it. Because what if it was to the 40th power? Are you going to really multiply it out 40 times? No. So again, the way I do this, again, I'm doing this in my head. I say, let's suppose I'm thinking this in my head. If u equal 3x squared plus 8, then du would be 6x dx. Do I have 6x dx? Yes, I do. It's right outside. I mean, close to it. It's the 6 needs to be is gone, but it's off by just a constant. We can do u substitution. So you kind of play out those scenarios in your head, and then and you see, all right, it's formula quote A. I mean, I'm just calling it formula A to make it easy. So divide both sides by 6 here. So x dx is equal to du over 6. So the integral of u to the fourth times x dx, which is du over 6. All right, you guys finish it here if you haven't done so already. So for Tuesday's class, just if you have any questions, it's just going to be like office hours, because I never have office hours, but you come in, ask me questions. I don't have anything planned. Hey, you can say I was studying over the weekend, but can you go over how to do questions so and so on this page, or this question on this test, or whatever? I can do whatever you want me to. Can you go over the mean value theorem again, or whatever you want me to? All right. Well, Omar, you can ask me some after end of class today as well. You don't have to wait for all of them on Tuesday. So let's factor out the 1/6. This is going to be formula A, where you just use the power rules. So it's going to be 1/5 u to the, 1/5 u to the 5th plus c. So you get 1 over 30 times something to the 5th plus c. What is u? Well, it's 3x squared plus a. And there you go. And that's our final answer. Any questions on that? All right, so we got oh, I missed a bunch of the chat. We charge by the grade. Let's talk about your childhood. Whoa, what the heck is going on here? Well, what was that in response to? We charge by the grade. Oh, therapy. Oh, thank you. Wrist hair. Someone wrote all caps. Wrist hair. Thank you, Miguel. Hey, I'm Persian, okay? You're going to have hair on your arm, okay? Look at this. All right, do you guys want a quick break before we continue? All right, 9 minutes, huh? Or no, we'll go with 10 minutes. You can come back at 4:06. All right. All right, so I finished number 10, so let's go to number 11. So you just take the antiderivative, 4x minus, this is a definite integral, so you're going to take the antiderivative, no plus c, you just plug in 2 minus, well, it's still plugging in 2, minus plug in 0, so you get 0. So 8 minus 8/3, so that's 24/3 minus 8/3, which is 16/3. Any questions on that? Oh, I was charging. Can you guys hear me okay? Sorry, I was charging my laptop. Was audio okay for that? It's okay. Yeah, I unhooked it now. So, okay. So, number 12. Let's do that one. The integral from 0 to 3 of x over x squared plus 5. So I want you guys to get to a point when you see this, it's screaming du over u form, or at least you try it out, because you look at it, you say, hey, the bottom, if we let that be u, which is x squared plus 5, the derivative of that is 2x, or I have 2x right above it. Close, it's just off by a constant. So here's what you would do. You would say, let u equal x squared plus 5. Let du be, well, what is du? It would be 2x dx. Do I have 2x dx above? No, but it's close. So I want to know what x dx is. So divide by 2, so you get du over 2 equals x dx. Now, what was he going to do? So when you rewrite this, be careful. This is a definite integral. It's, if you watch the video to the end, which I know some of you didn't, it's not from 0 to 3 anymore because it's x equals 0 to x equals 3. But now we have it in terms of u. So u is on the bottom. The x dx is du over 2. But the number that goes here and here are going to be different. So here's what you do. 0, if x is 0, what is u? Well, u equals x squared plus 5. So if x equals 0, u equals 0 squared plus 5, which would be u equals 5. So when x is 0, that produces u equals 5. Now, well, what if when x is 3, what is u then? Well, if x is 3, u equals 3 squared plus 5, which is 9 plus 5, which is 14. So in this, when x is 3, u is 14. So from x going from 0 to 3 is equivalent to u going from 5 to 14 in this question. Now, the nice thing about this problem is you don't ever have to go back to x's because your final answer is going to be a number. So you factor out the 1/2 from 5 to 14 of du over u. What is the antiderivative of du over u? It's natural log of u from 5 to 14. So you plug in the top number, which is 14. Now I'm going to leave the 1/2 factored out. Minus plug in the bottom number, which is 4. An absolute value is just still 4. So you can leave your answer like exactly what I wrote here. Or you could write it as natural log of 14 over 5. Why did I write 4? So either or. You can write it either like this or like that. And that's the exact answer. You don't want to put in your calculator and give me a decimal approximation. And this is all on post-it for you already. So let's go to number 13. You're given this information, the integral from 2 to 5 of f of x dx is equal to 10. You're also given the integral from 5 to 8 of f of x dx is equal to 4. So the question is, well, there's 3 parts. Part A, what's the answer to the integral from 2 to 8 of f of x dx? Well, that would just be, well, the same as it would be equal to, you adding them up. It's the integral from 2 to 5 of f of x dx plus the integral from 5 to 8 of f of x dx, which would be 10 plus 4, so the answer is 14. Right? If you want the area, if the area underneath the curve from 2 to 5 is 10, and then from 5 to 8 is 4, well, from the whole thing from 2 to 8 would be 14. And if it's not above the x-axis, it's still the same logic. You add them up. Part B. What's the integral from 5 to 2 of f of x dx? Well, the trick is that's the equivalent to the opposite of from 2 to 5 of f of x dx. Because remember, when you switch the limits, your subtraction is going to be reversed. So you're going to get opposite answer. So it's going to be negative 10. And then part C, the integral from 5 to 8 of 3 times f of x dx. You can always factor out a constant. So you got 3 times the integral from 5 to 8, that's given to be 4. So the answer is 3 times 4, which is 12. Does that make sense? All right, so focus on the old exams. I'm thinking 16 to 18 questions, somewhere around there. What you want to focus on, there'll be an optimization question, like a word problem. You had one on the last test, but remember I did different ones for you. Related rate, I'm not going to make it too difficult. It'll be like another triangle one if I ask you one, but at most one of these. But limit definition of derivative. I'll definitely ask you one question using, take you the derivative using the limit definition of the derivative. And your work has to be correct, good notation, limit as h goes to 0, so on. I will definitely make you do use substitution integral, probably more than one. I'll put probably, I don't know, maybe 1, maybe 2, I don't know. More than 1, probably, okay. Just go back and study the stuff like limits. Think of limit graphically, algebraically. Was that section 1.3 where you had the list of problems? Yeah, I remember I put a list of questions. I think it was like section 1.3 where I said find the log extreme. is what interval is increasing or decreasing, or what interval is concave up or down. And I did every single one of those part A, B, and C, and I posted the answers. So be able to tell me when something's increasing or decreasing. Concavity / point inflection. Again, I'm not saying I'm going to ask you every single one of these questions, but be ready for it. Let's see here. Just study every single question on an old test, like there are 10 or 12 questions exams, so it's not that many questions. But these are things you can focus on. Implicit differentiation, logarithmic differentiation. Chain rule. Anyway, just study the old all the other things I've done. Now here's the thing. I want to ask: is section, was it 5-1? I'm not going to ask you like, hey, find the area by creating rectangles and have a bunch of number crunching. Find L6 or something like that. I think the question I'm not going to do that. If I ask find the area, it's just you integrate quickly. I put hyperbolic functions, but you don't know x letters are ready for them. Just focus on the trig functions. Any particular questions? Ask away. Worst case, I'll say I can't answer. Go ahead. Let me know what you want to ask. Any questions? None. Well, this is awkward.
Just the best. I basically you answered the question that the best way to kind of study is to look past both exams and quizzes.
Yeah, and also once you looked at them, try to write it down and do it without looking at it, or just looking at the formula sheet, your notes, but don't look at like or get on like it from the book and try to do it. Can I zoom out? I zoomed out. Is that good? The iPad or me? Well, this is not necessarily like 4.3. I'm just saying I'm not saying I'm going to put every single one of those questions on there. Relative, extreme, increasing, decreasing. That's what I said. Up here, these will definitely be on there. But as far as other stuff, you're gonna have like about 16, 18 questions somewhere around there. I may pick up those. I might pick something else. But just be ready for it. Same format as your other exams, just a little bit longer. Instead of 10 or 12 questions, you'll have like 18 questions maybe at most. But you get 2 hours. And that's pretty much it. So study up. If you run into questions, Tuesday will answer some questions. Madison will actually volunteer that she will have an iPad and share her screen and show you how it's done. Right, Madison?
Yes, absolutely. That sounds like a great plan.
All right. Other than that, make sure you don't share your notes with anyone that missed class today. Make sure you charge some money. All right. Bye, everyone.